So we have a problem, count nice pair in an array. Let's understand the question first. So we are given an array nums that consists of non-negative integers, and we have a function which is reverse of x. What it does is like, it basically given a number 1 2 3, it reverses the number as in 3 2 1, right? So our question is like, we have to find a nice pair or a good pair. What they are called a pair of indices ij is nice if it satisfies all the following conditions. And what are the conditions? I must be less than j, and the num I and the reverse of the number j, num j, must be equals to num j plus reverse of the num I. Like this the two condition forms a good pair. We call it nice pair, right? So if we see this example, let's see it over here. So yeah, we are given with 42, 11, 1 and 97. So what we need to do is like, this is I, okay, and this position is j. So let's consider 42 and 97. So we keep 42 as it is, and we'll reverse this 97. After reversing 97, it will be like 79, and when you sum this, it will be becoming 121. Similarly, if we reverse the ith location, reverse I and add with num j, it will form 121. So this altogether becomes a nice pair. Similarly, if you see 11 and 1 in the example, 11 and 1, reverse 1 will be 1 itself, so it will sum to 12, and reverse of 11 will be 11 itself, and 1, it will form 12. So this is the question. We have to basically count the number of such pairs, such nice pairs. So let's look at another example which is given like 13, 10, 35, 24 and 76. So how should we solve this question? So if you see over here, we have 13, 10, 35, 24 and 76, right? And what we have to do is like, we have to find a pair after reversing it. So let's say I reverse entire array, given array, right? So reverse of 13 is 31, reverse of 10 is 0 1, which is 1, reverse of 35 is 53. Similarly, I have reversed the entire number. Now just observe over here. So our question was like, we have to sum this I and then we have to sum this I plus the jth item, right? It must be equals to, one second. So this should be reverse of j. I and reverse of j must be equals to reverse of I, right, and j. So if you see this equation, can we write something like I minus reverse of I, like I and then minus of reverse of I, okay, is equals to j minus reverse of j, or j minus reverse of j. Yeah, so we can write the above equation in like this way, okay. So what I am doing is basically, this is my I and this is my reverse of the I. So if I subtract that, and suppose this is the position where this is my j and this is the reverse of my j, right? So if I subtract that, it should be equal. So after doing this subtraction, I am getting an array which is this one. So now what I can say is, okay, which all can be formed a pair. So this 18, let me choose a different color here. So this 18 can be formed a pair with this 18, right? The same 18 can form a pair with this 18. Also, this 18 can form a pair with this 18, right? Like minus 18. And we also have this 9 can form a pair with this 9. So we have 4 such pairs, right? So if you understand this scenario, what we have to basically do is like, we have to reverse the entire array and subtract it, and then we have to count the similar numbers, like what is the number of occurrence of 18. So we have 3, right? And for this 3, how many combination of 2 can be formed? So what we can do is like 3c2, and 3c2 can be better be given by a formula which is like n minus 1 by 2. I hope you know this. So this will give us the total number of pairs that can be formed by n numbers. So we have to basically count these numbers and we have to apply this formula, and we'll get our desired answer. So for example, over here we have how many pairs can be formed? 4 pairs can be formed. How? So if you write 3, like minus 18 is 3 times, so 3c2 will be 3 itself, right? 3 into 2 into 1 divided by 2 into 1, which will be 3, and this 9 will be only from one pair. So we have 3 plus 1, 4 pairs. Let's look into the code for clear understanding how to code this in C++. Let me open my submission quickly so that it will be easier for you to understand this very quickly. Yeah, so we have to basically, first of all, we have to write a code to reverse our number, right? So what this will do is, this is a helper function. It will take a number and it will return a reverse number. So we are taking a number, and then while this number is true, this number is not 0, we are taking the last digit of that number by doing 10 modulo with 10. So suppose if I have 94, if I do modulo 10, I will be having 4 with this, right? So I have got the last digit, and I'll just, my answer is 0. So 0 into 10 will be 0 plus 4. I have 4 in my answer as of now. I'll divide this by 10. So 94 divided by 10 will be 9. So again, 9 is a positive number. I'll do it modulus with 10. I'll get 9. So my answer will be, it was initially 4, right? 4 into 10 will be 40 plus 9. So I have 49 over here. Now I divide that 9 with 10 and I'll get 0. So this while loop, while 0, it will be false. So it will return the answer, which is 49. So in this way, it will reverse the number. Any number you pass in this number, it will reverse the number and give the output. Now what we do is, like, we will create a vector which will contain the difference between the number and the reversed number. So for this, how we can do is, like, for every number, for every num from the entire numbers, the array num array, we will push back the difference between those in the diff array, diff vector. So num minus reverse of num. So we will be having a vector diff which contains this kind of scenario, right? Now how to find the count of these count of each similar numbers? We can use map as well, but let's not use map, and we can do it simply by sorting the array. So what we'll do is, like, we'll sort this this array, and for our first array we'll initialize and like this element. So for our first thing, suppose we get minus 18, so we'll initialize yearly with minus 18, and our current count will be 1. So we have just encountered one such number. Now what we'll do is, like, we'll loop through the second element, like from 1 to the different size of difference. So we'll loop through this 9 minus 18, but which it will be sorted. So what we have is, like, if the difference of ith item, the item which are seeing, is equals to element, we'll just increase our count. That's it. So till then we'll get the same number, we'll increase our count. And if the number is not same, if we are encountering some different number even after sorting, so what we'll do is, like, we'll push that into the answer. So our answer will be, initially our answer is 0, answer plus this n into n minus 1. N is our current count, is our basically n, how many numbers we have of the similar count, right? So n into n minus 1 divided by 2, and we are doing modulus because the number can be very high. You can look at the problem statement. So we have initialized our modulus with 10 to the power 9 plus 7, right? And then we can, if we encounter any different number, we'll initialize our current count with 1 itself, okay? And then after again we initialize our current count with 1, and now our another element, the element initialization will be that different element which we have encountered, right? And in similar fashion, once our loop will be finished, we have to once again do since we will having this count, and we have to again add this count in our answer. So we'll update our answer again, and then we'll return our answer. So let's understand this code by implementing in an example. So suppose I have some sorted array such as, like, suppose 2 2 2, and then suppose 5 5, and then let's say 6 and 6, something like that. Let's do a dry run over this. Yeah, so what we'll see is, like, our code will firstly our loop will run start from here, right, from the ith position, 1st position, because our ELE will be pointing to, like, EL will be storing the value 2. Now we'll check, we'll run the code. And our count will be basically 1, right? Count will be 1, count equals to 1. So when we run the loop, so we'll encounter 2, we'll update our count with 2, we'll again encounter again 2, we'll update our count with 3, right? And once we encounter 5, we will once we encounter a different number, we will update our answer, right, and we'll again initialize our count to 1. And now we are looking at this location, and our element will again be storing this value 5, right. We'll again go through the loop. Our count will be 2, will be here, our count will be 2. Again we'll jump over here. Now it's not similar with what our element is having the value, it is a different. So our else block will run, and we'll add this answer, the n into n minus 1 by 2 part in our answer, and again we'll initialize our count with 1 and the element with 2, right. Count with 1 and element with 2, sorry, not 2, element will be now having 6. Again we'll loop in, and we'll have this 6, and now again if we go out, our loop will be ended. But to address this count, right, this last portion thing in our answer, we again have to write this code wherein it will add this portion n into n minus 1 portion in our answer. In this way we have to write this code. I hope you have understood the code. Thank you.